Welcome, everyone. Let's get started on one of the most fascinating and critical developments in modern artificial intelligence. Today, we are exploring the ASL-3 trigger and how Anthropic's Claude Mythos model fundamentally shifted the cybersecurity landscape, becoming the first AI deemed too dangerous for public release. Let's begin by defining our core subject. What exactly is Claude Mythos? Developed under the internal codename Capybara, Mythos is Anthropic's most advanced frontier model, sitting in a tier entirely above the Opus models. While it excels across all academic benchmarks, its cybersecurity capabilities are what truly set it apart. The basics are staggering. During pre-deployment evaluations, Mythos autonomously identified thousands of zero-day vulnerabilities across critical, real-world software. This brings us to why it was fundamentally restricted from public APIs. Under Anthropic's responsible scaling policy, models are evaluated against strict safety thresholds. Mythos triggered the ASL-3 threshold, which is defined as a model capable of providing meaningful uplift to actors seeking to cause significant harm. Because it essentially acts as an autonomous zero-day factory, releasing it to the public would be equivalent to handing advanced hacking capabilities to anyone with a laptop. Take a look at this flowchart, which illustrates the deployment decision matrix. When Claude Mythos entered its rigorous evaluation phase, Anthropic's red teams assessed its capabilities against their safety frameworks. The central decision node here is the ASL-3 threshold. Because the model demonstrated severe offensive cyber capabilities, the flow shifts to the crossed path, recognizing a high misuse risk. Instead of moving to a public API release, the model was heavily restricted. This ultimately routed the technology into a secure, defensive coalition known as Project Glasswing, ensuring the AI is only utilized for patching systems safely. To deeply understand the ASL-3 trigger, we must look at Anthropic's Responsible Scaling Policy, or RSP. What is the RSP? It is a voluntary, rigorous framework designed to manage catastrophic risks as AI systems scale in power. The basics involve categorizing models into AI safety levels based on their capabilities. ASL-1 and ASL-2 represent models with manageable safeguards, like the current public Claude models. However, ASL-3 is triggered when a model can provide meaningful, catastrophic uplift to bad actors. Why does this matter? Because Mythos proved it could operate as an autonomous hacker, bypassing standard security controls and chaining exploits. How is this measured? Anthropic uses expert red teaming to test the model's autonomy before release. When Mythos began discovering unpatched bugs in hardened environments, it proved that human speed patching could not keep up with machine speed discovery. Therefore, the RSP dictated that deployment required substantial additional safety measures, halting its public release. This diagram provides a simple, left-to-right progression of Anthropic's AI safety levels. On the left, we have ASL-1, representing minimal risk, moving into ASL-2, which covers current public models with manageable safeguards. The critical pivot point is ASL-3, highlighted here in red. This is the exact classification where Claude Mythos currently sits. It represents a threshold where the AI can provide significant uplift for harmful activities, such as advanced cyber attacks. Finally, on the far right, ASL-4 represents future models with catastrophic risk potential. Crossing into ASL-3 is what officially halted Mythos's public rollout. Moving forward, we must examine the core capability that alarmed researchers: autonomous zero-day discovery. What is a zero-day? It is a critical software flaw that is completely unknown to the vendor, offering 0 days to patch it before hackers can exploit it. Traditionally, finding these requires weeks or months of specialized human intuition. Why is Mythos a paradigm shift? Because it replaces manual human search with rapid, autonomous semantic analysis, reasoning through millions of lines of code to spot edge cases. How effective is it? The results are staggering. During testing, Mythos autonomously identified a 27-year-old vulnerability in OpenBSD. OpenBSD is globally renowned as one of the most secure operating systems, running firewalls and critical infrastructure. The fact that an AI could instantly uncover a flaw that survived nearly 3 decades of human scrutiny proved that Mythos was fundamentally operating at a superhuman level in vulnerability discovery. This comparison chart beautifully illustrates the stark contrast between traditional cybersecurity and AI-driven methods. On the top path, traditional bug hunting requires weeks or months of painstaking human effort, yielding very few zero-day discoveries. On the bottom path, Claude Mythos utilizes high-token semantic analysis. This process condenses the timeline down to mere minutes or hours of compute time. The output, thousands of 0 days discovered autonomously. This structural efficiency is exactly why an AI model of this caliber cannot be distributed through open APIs without proper guardrails in place. Finding a bug is one thing, but weaponizing it is another. Let's deep dive into exploit generation and chaining. What is vulnerability chaining? It is the process of identifying multiple lower severity issues and linking them together to forge a single, critical exploit path. The basics of Mythos's power lie in its ability to not just flag bad code, but to act as an autonomous operative. How does it do this? In testing, Mythos successfully chained together several vulnerabilities in the Linux kernel. It bypassed kernel address space layout randomization, manipulated heap objects, and granted itself full root permissions. Let's look at another case study. Anthropic tested Mythos against Mozilla's Firefox 147 browser. While previous models like Opus 4.6 managed only 2 successful exploits out of hundreds of attempts, Mythos developed 181 working JavaScript shell exploits. It is this jump from theoretical vulnerability to functional, automated weaponization that defines the ASL-3 boundary. Here we see a sequence diagram mapping out the concept of vulnerability chaining. The AI, Claude Mythos, initiates the attack by exploiting a low-severity bug to leak memory addresses. Using the information returned, the AI dynamically adjusts its strategy, targeting a second low-severity bug to bypass security randomizations like KSLR. This sandbox escape gives the AI the exact positioning it needs to execute a final root privilege escalation on the target system. It perfectly visualizes how minor flaws are stacked by an intelligent agent to create a catastrophic breach. To truly appreciate this capability, we must look at a real code analysis. Mythos autonomously discovered a 16-year-old vulnerability in FFmpeg, a media library used globally for encoding and decoding video. What is terrifying is that traditional automated security tools hit this exact line of code 5 million times without ever catching the problem. Here is the technical breakdown. Developers used a standard C programming idiom, memset, table -1 size, to initialize a table of 16-bit integers. This sets every byte to 0xFF, resulting in a value of 65,535, which was intended to act as a safe sentinel value, meaning empty. However, Mythos's semantic reasoning realized a blind spot. How, if an attacker crafts a malicious video frame containing exactly 65,536 slices, the valid slice number 65535 perfectly collides with the sentinel value. The software is tricked into thinking a non-existent neighbor is real, triggering a critical out-of-bounds memory write. Mythos understood the hardware-level implications of AC idiom. This flowchart demystifies the FFmpeg code vulnerability. On the left, the software initializes a table using memset -1, filling the memory with 65535, the sentinel value. Concurrently, a malicious video frame is fed into the system containing 65,536 slices. These two paths converge at the collision check. Because the highest valid slice index is exactly 65,535, it mimics the sentinel value perfectly. The system's logic fails, directly leading to the red box, an out-of-bounds memory write, and a system crash. The AI perceived this systemic failure autonomously. So, why not just release it to security researchers? This introduces the dual-use dilemma. What is it? The exact same semantic reasoning used to proactively fix a bug can be weaponized to exploit it. The basics of modern threat modeling are shifting. Historically, defenders had time between a vulnerability's discovery and its exploitation. With frontier AI, that patch window has collapsed from months to mere minutes. Why is this so dangerous for the enterprise? If Mythos were publicly available, threat actors could orchestrate an army of agents that autonomously scrape the internet, craft personalized spear phishing attacks, and execute rapid lateral movement across internal networks. The ultimate consequence is that traditional, human-speed security operations centers, or SOCs, are fundamentally unequipped to handle this. When attack cycles are measured in seconds, organizations must rely on AI-driven defense platforms to survive. Observe this dual-use pathway diagram. From the core AI model capability on the left, we branch into two realities. The top path is the ideal, using the AI for defensive patching, resulting in strengthened global security. However, the bottom path represents the risk of open access, offensive exploitation. This leads directly to machine speed attacks. Because traditional enterprise security relies on human triage, the flow terminates in the red box, human defenses overwhelmed. This architectural bottleneck is the primary reason the ASL-3 trigger necessitated a closed, controlled ecosystem for deployment. Faced with this immense power and the strict boundaries of the ASL-3 trigger, Anthropic created a groundbreaking real-time use case, Project Glasswing. What is it? It is an exclusive, defensive cybersecurity consortium. Anthropic partnered with the heaviest hitters in the tech industry, including AWS, Apple, Google, Microsoft, CrowdStrike, and Palo Alto Networks. The overarching mission is to proactively deploy Claude Mythos to scan, identify, and secure the foundational software of the internet before bad actors can acquire similar AI capabilities. How is this being funded? Anthropic is putting its money where its mouth is, committing up to $100 million in model usage credits for these partners. Furthermore, they're injecting $4 million directly into open-source security organizations. Glasswing transforms a potential cyber weapon into an elite, automated shield for global digital infrastructure. This structural diagram illustrates the flow of Project Glasswing. The heavily restricted Claude Mythos API sits at the top, distributing access solely to the Glasswing Consortium. From there, the power is divided among the partners based on their specializations. Cloud providers like AWS and Google use it to scan and patch cloud infrastructure. Microsoft and Apple deploy it to secure global operating system ecosystems. Finally, security firms like CrowdStrike and Palo Alto Networks utilize the AI's logic to radically update their threat detection engines, creating a synchronized, global defense web. So, where do we go from here? We are rapidly entering an era of machine-speed defense. Because attackers will soon automate zero-day discovery, human-speed security is dead. The basics dictate that organizations must rethink their architecture. For instance, identity security platforms like Okta are becoming critical kill switches, ensuring that autonomous AI agents cannot execute unauthorized lateral movements. How must enterprises adapt? They must adopt shift-left security, deploying defensive AI directly into the software development lifecycle to break their own code before adversaries do. While this transitional period will be turbulent, the long-term outlook is optimistic. AI will eventually help us produce software with virtually zero security flaws. Thank you for joining this session. Please like, subscribe, and visit quicktechie.com for premium certification prep, including Q&A banks, full ebooks, audiobooks, full-length training, and interview guides. Our final flowchart maps the future paradigm of secure software development. It starts with AI development, flowing into AI-assisted coding. Crucially, the code is immediately subjected to machine-speed security scans, acting as an automated red team. Before deployment, everything must pass through identity and zero-trust gates to ensure strict access control. This secure pipeline terminates in the green box, a hardened production environment. This is the ultimate goal of recognizing the ASL-3 trigger using AI to build a resilient digital future.
To find related ebook and other material for this training course, go to quicktechie.com. Now you will see all the video courses are available here. So let's move to the ebooks. You can go here, ebooks, all AI related ebooks like you are watching currently Mythos related training. That ebook would be uploaded under this section. You can download this ebook. PDF would be available, all 300-page PDF. So you just click on the download this entire ebook. You can download from this section. So whatever training you are currently listening, corresponding ebook would be available. We have thousands of ebooks available. Now, other than that, we have on video courses which you are watching right now. This also all AI related courses are available. Similarly, for all company related trainings are available like Microsoft. You can find it here with their respective certification training modules. All exam simulators which would help you to get the certification preparation. Just refresh if you get this kind of error. Okay, so now you can see these are all certification preparation materials. Will also be click here to the NVIDIA certification preparation material. So you can see all NVIDIA certification preparation materials, and click on any of this and it would load the entire screen and you can launch the practice paper. So this is what you can see, that you can submit the answer. We have an audiobooks available. Okay, so for each section, and these are our alumni who can you can find out all alumni who are accessing our portal.